Friends, so today also we are taking these problems related with the torsion because in these problems the shaft which is having a more than one pulley that is mounted. So according to that such type of the problems that is in the machine designs also. So that's why today I am taking this problem. So please note down a solid circular shaft has a uniform diameter of 50 mm and is 3 meter long and its midpoint (50 kilowatt) is delivered to the shaft is used to drive to machine one at the left of shaft consumed 20 kilowatt and other at the right end consuming the remaining 30 kilowatt. Determine the maximum shear stress in the shaft and also the relative angle of twist between the two extremes and to the shaft runs 200 mm RPM and the material is used steel for which C equal to 85 giganewton per meter square. Right. So here first we will draw figure. This is a shaft. At the middle, having pulley. At the end, against one pulley, and this is also one pulley. So this is 30 kilowatt, and this is 20 kilowatt. This is 50 kilowatt. Shaft diameter. This is 50 mm. This is also 55. Length equal to 3 meters. These two machines, one. So as per the descriptive, we draw that figure, determine the maximum shearing stress in the shaft, and also because here 20 kilowatt and this is, so definitely here shear stress at the 30 kilowatt more, angle of twist also at the right hand. Suppose this is A and this is B and this is C. So that's why (50 kilowatt). So torque for AB equal to 60 into 10 to the power 6 multiplied by P divided by 2 pi N. 60 into 10 to the power 6 multiplied by P. This is 20 kilowatt. 2 pi RPM equal to 200 RPM. (60 into 10 to the power 6 multiplied by 20 divided by pi divided by 200). So this is 0.9549 into 10 to the power 6 Newton mm. Similarly, for BC, 60 into 10 to the power 6 multiplied by 30 and divided by 2 pi into 200. So this is multiplied by 1.5, 1.432 4 into. So after that, first bit, shear stress, maximum shear stress. So here formula, because now T divided by polar moment of inertia and tau divided by Rs. So this is T equal to tau multiplied by d by 2, and this is pi by 32 d raised to 4. pi by 16 into d cube. So for AB equal to, so this is tau is to be calculated. So 16t modified 16t into pi d cube. So this is for AB. This is 0.9549 10 to the power 6 divided by pi into d equal to. So I think d equal to 50 cube. Shear stress AB equal to 16 divided by pi divided by 50 cube. This is equal to 38.90 megapascal. Similarly, for BC equal to T BC divided by pi d cube 16 into, so this is 1.4324 10 to the power 6 divided by pi into 50 cube. Here if we multiply it by 1.5, you will get this is 58.36 megapascal. Similarly, means now shear stress, angle of twist. Now we know this is shear stress. Angle of torque is also known. So that's why for angle of twist equal to, so we have to use any relations. Suppose this is T by polar moment of inertia equal to C theta divided by L. So this is theta AB equal to TAB, length of AB shaft divided by polar moment of inertia for AB and divided by C for AB. So that's why this is for AB 0.9549 into 10 to the power 6, length 1.5. So this is, and polar moment of inertia pi by 32, 50 raised to 4, and that is 85 into 10 to the power 3. So this is equal to into this is equal to multiplied by 180 divided by pi 0.9549 into 10 to the power 6 multiplied by 1500 by 32 divided by pi divided by 50 divided by 85 divided by 1000 multiplied by 180 divided by pi. This is equal to 1.573 degree. And similarly for BC shaft, this is 14324 into 10 to the power 6, 1500. Again here pi by 32, 50 raised to 4. So this is 1.5 times, because this is 1.5 times greater. So that's why this is 2.360 degree. Means angle of twist for BC shaft is more as compared to angle of twist above the AB shaft. So note down next problem. So in this problem, second problem, a solid, okay, note down second problem. A solid cylindrical shaft is to transmit 350 kilowatt at 100 RPM. If the shear stress is not to exceed 80 find its diameter. Second bit, what percentage of saving in weight would be obtained of this shaft is replaced of this shaft is replaced by a hollow one whose internal diameter equals 0.6 of the external diameter if the length of the material, if the length of material and the shear stress and the shear stress being the same, find B beat. Find the polar modulus of a circular shaft of diameter 200 mm. So first read carefully the problems. So according to that we can solve the problem. 350 kilowatt. So power is given means first whatever may be the calculate. It's a torque T equal to 60 into 10 to the power 6 multiplied by P divided by 2 pi m. This is 350 divided by 2 pi rpm equal to 100. 60 10 to the power 6 multiplied by 350 divided by 2 divided by pi 100. So this is 33.4225 10 to the power 6 Newton mm. If the shear stress is not to exceed, so first beat if the shear stress is not to exceed, so T divided by polar moment of inertia equal to tau divided by R's, or otherwise tau equal to, so this is modified formula 16T divided by pi d cube, because T divided by pi by 32 d raised to 4 equal to tau divided by d by 2. So this 1d will get cancelled and this is, so this 16 T divided by pi d cube and this is equal to tau. So try to understand. So that's why I am taking, this is popular formula, tau equal to, and this is for solid. So d equal to 16T divided by pi into tau. This is cube under root 16 into 33 4225 10 to the power 6 divided by pi into 80 multiplied by 16 divided by pi divided by 80. This is equal to 128.61 mm. So what percentage of the saving in weight would be obtained of this shaft is replaced by a hollow shaft whose internal diameter is equal to 0.6 if the length of the material and the shear stress having the same. So yes, T for solid divided by polar moment of inertia for solid equal to tau for solid divided by R. This is right? Yes. Similarly, T for hollow divided by hollow, and this is for solid and this is for hollow. So that's why now you can write this is T for solid divided by IPS divided by this RS goes in the that sides, and this is solid, and similarly hollow divided by IPH divided by this is to H. Now here's similar T solid, because this is to be replaced equal to hollow, and TS because same material is tau H. So that's why this will get cancelled. Now what is remaining? IPS divided by RS equal to IPH divided by RH. So this is the ratio, means pi by 32 capital small d raised to 4 divided by d by 2, and this is pi by 32 capital D raised to 4 small d equal to 0.6 capital D, divided by, so this ratio is nothing but IPS, this is polar modulus. So this ratio polar modulus. So polar modulus, it is a ratio of the, please remember this formula, polar modulus equal to a ratio of moment of inertia, polar moment of inertia, polar moment of inertia divided by radius, or this is IP divided by R. So this is called polar modulus. So this is very important as per the multiple choice of the questions. This is very important. Now this pi by 32, this will get cancelled, and this 2 will get cancelled. Now d raised to 4 capital D raised to 4 into 0.6 0.1296 d raised to 4 divided by d. So here this is 1 d will get cancelled and this is d cube. So d cube equal to how much? So we already calculated, this is 128.6 cube into minus 1, this is 0.8704 d cube. So that's why 1 divided by 128.6 cube divided by 0.8704, this is equal to, and this cube under root. So d equal to 134.68, right? Okay. So here's again we have to calculate the percentage of the saving. So percentage of the saving means weight of solid shaft minus weight of hollow shaft divided by weight of solid shaft. So this is equal to density multiplied by area of solid multiplied by length equal to density of solid, this is 4 AH multiplied by H, this is solid. So this will be get cancelled because density and length same. So that's why here you can say area of the solid minus area of hollow divided by area of solid. So because in the previous problems you may be confused why sir is minus 1 by. So that's why this is basic formula. Now area of the solid pi by 4, I think this is 128.6 square minus this is pi by 4 into 134.68 square minus, now this is multiplied by 0.6, small d equal to 80.81 mm. So here's 80.81 square bracket close. This will get cancelled. Now one 128.6 square minus bracket 134.68 square minus 80.81 square bracket close divided by 128.6 square equal to, so this is 0.2980. So percentage of the saving equal to, directly you can write this is 29.80. So second bit, polar modulus. So polar modulus equal to, as we know, formula pi by 32 d raised to 4 divided by d by 2, means this is pi by 16 d cube, and this is given 200. Pi divided by 60 multiplied by 200 cube equal to 1.570 10 to the power 6 unit mm cube. This is your expected answer. So please note down today's third problem. A solid aluminum. So this is the different material. Third problem is solid aluminum shaft (1 meter) long and 50-meter diameter. Is to be replaced by a tubular steel shaft of the same length and the same outer diameter, that is 50 mm, such that if the two shafts could have the same angle of twist of the two shafts have the same angle of twist for unit torsional moment. Over the total length what must be the inner diameter of the tubular steel shaft? What must be inner diameter of the tubular steel shaft being modulus of the rigidity of steel is 3 times that of aluminum. So in this problem, 2 different material. So in the previous all problems material is the same, but in this problems material is different. This is solid aluminum, hollow steel. We'll see what we can do. Is to be replaced by a tubular steel shaft of the same length, aluminum 1 meter long and 50 mm diameters. So this diameter equal to 55. Is to be replaced by tubular steel shaft of the same length and the same outer diameter. So outer diameter equal to 55, inner diameter we don't know. So that's why once again we can apply now the same angle of twist, tubular shaft of the same and the same outer diameter, such that 2 shafts have the same angle of twist. Torsion moment. So torque that is to be transmitted for solid, and this is divided by solid equal to C for solid shaft and this length of the solid. For hollow, and this is for hollow, C for hollow, and this length of hollow. So this is given length equal same, LS equal to LH, TS equal to TH, and theta S equal to theta H given. So that's why here and this will get cancelled and only IP solid equal to and this is 1 divided by C solid, otherwise this is I write here solid divided by this is solid divided by T hollow, polar moment of inertia hollow equal to C hollow and this is length hollow. So this will get cancelled, this is also will get cancelled and this will get cancelled. So what is remaining? IP hollow divided by IP solid equal to C for solid and C for hollow. So that's why can I write polar moment of inertia for solid equal to multiplied by C for solid equal to polar moment of inertia for hollow shaft multiplied by this is hollow, right? So what is given? I think one another condition is given. Modulus of rigidity of steel is 3 times. So this is 3 times hollow, and this is polar moment of inertia for solid pi by 32. This is 50 raised to 4, and this is pi by 32. 50 raised to 4 minus d raised to 4 into C hollow. So this will get cancelled. This is also will get cancelled. Now what is remaining? 3 into 50 raised to 4, 50 raised to 4, d raised to 4. So I am making mistake. So instead of the solid, you have to consider this is aluminum. This is aluminum. 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 This is aluminum. So that's why this is aluminum and this is aluminum. This is for steel. This is for steel because this is C for aluminum equal to 3 times C for aluminum. So this will get cancelled, multiplied by 3. So 3 into 50 raised to 4, 3 d raised to 4. Now 4 d raised to 4 equal to 3 into 50 raised to 4. Zero 0.75 multiplied by, so d equal to This is equal to 46.53 mm. So what may be the answers? .53 is the expected internal diameter of the means wall thickness is very less for the steel shaft. So due to limitations of the time, today I stop here and we will continue means shaft of the parallel shaft in the next class.